let us discuss S and D block elements. You will be surprised at the heading. Why it is S and D together, you will come to know in a few minutes from now. Look here first. First statement, all S, D and F block elements, 3 blocks of elements S, D and F, all S, D and F block elements are metals. Elements are metals. Of course, I am not referring to hydrogen, because hydrogen belongs to its own block. You can't say hydrogen strictly belonging to S block. Hydrogen belongs to its own block. Right. Why? Why it is like that? All of them have 1 or 2 electrons only in their outermost shell. If you look at S block elements, their electronic configuration is ns122, and D block elements, it is n-1d 1 to 10 and ns sometimes 0 to 2. There are 1 or 2 elements with ns 0 also. Palladium, for that matter, is 4d10 5s0. So, and F block elements, it is n-2 f 1 to 14 and n-1 d sometimes 0 or sometimes 1, but ns 2. What is that you should observe? All of them have 1 or 2 electrons in their outermost shell. 1 or 2. Here you have 1 or 2, here you have 1 or 2, 2. So, what if they have just 1 or 2 electrons in their outermost shell? They have a tendency to lose the electrons, and an element which has a tendency to lose electrons is said to be electropositive, and it is said to be a metal. So, you should not just study about S block. It is S, D, F, all blocks, they are all metals, because they have 1 or 2 electrons only in their valence shell. Valence shell. So, what if they have 1 or 2 electrons? They will have a tendency to lose. They are ready to lose, and the readiness to lose electrons is mainly electropositivity and metallic character. Now, second point, S block elements are soft and they can be cut with a knife. S block elements are soft and they can be cut with a knife. Look at that statement. They are soft, no doubt. Are they softer than butter and cheese? Nay. They are softer when compared to D block elements. They are softer only when compared to D block elements. Therefore, whatever statement we speak in S block, we keep in mind D block only. When I say S block elements are soft, they are softer than D block. When I say S block elements exhibit fixed oxidation states, I indirectly mean that D block elements exhibit variable oxidation states. Okay? Why it is like that? So, the answer to all these questions lies in here. Any question on D block, where exactly minus 2b, I am not referring to 2b, zinc, cadmium, mercury. D block minus 2b, they are called transition metals. They are called transition metals. So, I am referring to these transition metals. Any question on transition metals. What are transition metals? D minus 2b. 2b, what are the elements? Zinc, cadmium, mercury. So, any question, this is most of the time the answer. Not only ns electrons, but n-1d electrons also participate. They also participate. Participate where? Participate in whatever area you are talking about. For example, the metallic bond in S block is very, very less. metallic bond strength is less, whereas in D block the metallic bond strength is very high. Why? Not only Ns but N-1d electrons also participate in transition metals.